Our guest speaker, Neil Leach. I had the pleasure to work with Neil for many years now. More importantly, we have co-edited 2 books together, one 3D printed body architecture in 2017, another was interactive design, which actually traces a lot of these ideas about cybernetics, but also more to contemporary practices in 2023. Neil, sorry, I just had a Zoom. Neil is an architect and professor from UK. He taught in many different schools at USC, Columbia, Harvard, and right now he's director of a DDes program at FIU. If you're not familiar with DigitalFUTURES, he is the director of a Digital Future, completely online program for opening the education for across the globe. So they have a lot of tutorials, discussions, incredible lineup of speakers that happen every week. So I encourage you to follow DigitalFUTURES. And he wrote many books, among which his latest books on AI and theory of AI for architects has gone very popular. He's been touring around the world, and he was here for a conference. And I invited him to give this lecture, and so we are very honored to have him. And thank you so much. So with that, I'm just going to pass it to Neil.
Oh.
There, this is here. And sure your camera. Sorry, can I make sure your somehow your screen is not shared?
No, it's not. Huh?
No, here the projector is not. Sorry, can I just? Is it possible to present from my laptop?
Yes.
Oh, let's do that because for some reason it doesn't recognize. Let's see.
It's going to be a long way down here. Everything gets reconfigured.
Maybe we can arrange it by date so we can see which one.
Yes. Oh yeah, there we are. Should I put it on your laptop?
Yeah.
Okay. Sorry. Can I just go back and share sound as well? Sorry.
Okay, I'm going to unshare, and then we are sharing.
Sound not nice. That one's not. Yeah.
Yeah. Okay. Great.
Is that it?
And welcome to Hiroshi as well to join us. Thank you so much.
We met actually in Ars Electronica.
Oh, several years ago. Right.
Yeah.
Let's come to my logical art.
Yes.
Oh, great.
Yeah, of course.
Something is echoing, yes. Hiroshi, maybe your laptop. I think something is echoing and I'm not sure.
Okay, sorry, that's mine. Okay.
Yeah.
No,
Is-
it's echoing, which is weird. Is your laptop connected? Is it possible to disconnect from your laptop? Okay, sorry everyone, we are about to start a little. So we have about 17 people on Zoom and 35 people here.
Is it stopped?
I think so. Perfect. Thank
Right.
you.
Thanks. Great to be here. There's a lot of stuff on digital futures that we've been doing. Catherine Hales was yesterday, unbelievable talk, bacteria to AI. Last week we had Stephen Wolfram, and before that, Kalarati, and so on and so on and so on. There's a lot of stuff on digital futures. If you just go Digital Futures International, then then go to the YouTube channel, and we have a thing called Doctoral Consortium, where we put, it's designed to basically have a global platform for doctoral students worldwide. And there's a lot of interesting stuff on neuroscience, especially. And what I want to do today is kind of try and bring this together into a coherent whole. I've never given a lecture on spatial intelligence before, so this is very specially done, and it's trying to assemble all those fragments into something that is vaguely coherent, but it is new, so I'm going to rely on notes to some extent. I also, if you want to ask questions later, I'm on Instagram, and how do I move forward? Okay. Yeah. So, since Banaz was talking about her university, let me start off by talking about my university, University of Cambridge. You probably know that these two individuals got Nobel Prizes for, not for AI, but Geoffrey Hinton for physics and Demis Hassabis for chemistry. What you probably don't know is that Geoffrey Hinton studied architecture for 2 days at the University of Cambridge before he decided that architecture was not for him. I got a friend at Foster and Partners who said, he's smart. It took me 5 years to realize architecture is not for me. But what's interesting about these two individuals is that they actually came into AI largely through neuroscience, through trying to understand the brain. Demis Hassabis actually did a PhD in neuroscience before going on into AI. He's now the CEO of DeepMind. Geoffrey Hinton was really interested in how the brain worked, and it was only by modeling it in neural networks he got into it. Anyway, they both received the Nobel Prize, both from graduates of the University of Cambridge. And what I want to do today is really try and pair off these two different domains of neuroscience and AI, because Anil Seth, I don't know if you know Anil Seth, but he has the most incredible TED Talk with 60 million something views. Anil Seth did the opposite. He did a PhD in AI, and then he moved into neuroscience, also from the University of Cambridge. What is interesting, when I wrote the first edition of my book, this is the second edition, it became very clear to me that neuroscientists and AI people weren't interested in artificial intelligence. They were interested in intelligence. And this is a quote from Demis Hassabis. Our ambition at DeepMind is to build intelligent systems to help find solutions that can learn to solve any complex problem. Put another way, we want to use it to solve everything else. And what he meant by that, I mean, this is kind of well known, the AlphaGo episode. I write about that a lot. I won't talk about it now, except to say that what they said when they were doing this was, we're not interested in the game of Go. I mean, Demis Hassabis had been a chess prodigy, so he was interested in games, but they were just using it to test out systems that they were going to apply later on. And interestingly enough, AlphaGo Zero, the subsequent model, was used by Wan Yu He for LookX School. Wan Yu is my doctoral candidate, or was now a PhD candidate at Tongji. And then, of course, Demis Hassabis used the principles to produce AlphaFold. I think Demis Hassabis is absolutely brilliant. He is the one person I completely trust. But there was actually another person from the University of Cambridge who should have got a Nobel Prize, Alan Turing. Now, tragically, of course, he committed suicide in 1954. And that was before the term AI was coined. So maybe I'll do a little sort of take on Benaz's comments. These are the dudes who, in 1956 or 1955, they invented the term artificial intelligence. And you can see Minsky at the back there, Claude Shannon here. And they were the cool young things who wanted to solve the basic problems of AI within 2 years. That never happened. In fact, it kind of got embarrassing to some extent. There were the other things, there were a lot of, it was hyped up. There were a lot of winters that came because of, it wasn't measuring up to the standards, and so on and so on. In particular, there were things like they wanted to understand what the Soviets were saying. They wanted to use it for translation. And actually, my book's been translated using AI into Chinese and into Italian right now. But it was useless. There was one particular case when they tried to translate "out of sight is out of mind," and they came up with "invisible lunatic." So there were kind of jokes going around. It was the butt of jokes. But the point about this meeting, there was someone conspicuously missing from this thing, and that was Norbert Wiener. Well, first of all, he's from a different generation, right? I mean, when you look at John McCarthy's age, John McCarthy was 30 years, born 30 years later. And he's I mean, he looks a little stuffy, right? He's using a blackboard and things. You can't imagine him lounging around on the grass like those kids, right? But the important thing was actually, this is where I disagree with Ben, the term AI already existed within the broader field, or rather, what we call AI already existed within the broader field of cybernetics. And what they wanted to do was try and differentiate what they were doing from the field of cybernetics, largely because it was a huge term covering all these different things. And also they were very skeptical about the biological. Wiener wasn't invited to the party, right? Instead, you got John McCarthy, who was the one who coined the term. And he already was interested in what we came to call symbolic AI, based on logic as opposed to connectionism, based on neural networks. That was the big battle that was being played out over the next few years. And he was interested in engineering rather than mimicking biology. So there was a split. When the term artificial intelligence was coined, the cyberneticists went one way towards life, and those interested in the mind moved towards largely symbolic computing. But the term artificial was actually, we look at it now and think that's a terrible term. You would never want to call it, you want to use that term. And I quote some people in my book that say that. But actually, if you put yourself back into the 50s, artificial was a cool term, right? I thought this was a spoof advert, but this is a real advert from the 50s, right? Fluorescent tubing, wow. What does it say here? It's cool. I mean, really? So, I think after the Second World War, there was a kind of belief in technology and the future and everything kind of, it was an era of nylon, of artificial fabrics and so on. Artificial was not necessarily such a pejorative term. But what I want to point out was that actually in this battle for supremacy, I mean, connectionism based on neural networks versus symbolic AI based on logic, actually there are 5 different tribes, as they're called. There wasn't just them, but these are the 2 dominant ones. And the unfortunate thing for neural networks is that there was a series of, I would say, tragic accidents that happened over the course of time. I mean, this is Alan Turing, this is the letter that he says, and I think what's interesting in the first paragraph, in working, he says, I'm more interested in the possibility of producing models of the action of the brain than in the practical applications of computing. Now, that's astonishing. That's astonishing. And this is kind of, he was really interested in the biological. And tragically, of course, he committed suicide in 1954. Von Neumann also. This is a book that was published posthumously, The Computer and the Brain, with a foreword by Ray Kurzweil. Von Neumann also died tragically early. We know he died of cancer. The suspicion is it was because he was part of the Manhattan Project and got exposed to radiation. We don't know. But had these 2 characters been around, maybe history would have been different. And then, and frankly, this is where Marvin Minsky is the villain in the piece, because he wrote a book with Seymour Papert about perceptrons, basically saying they're going nowhere. And this was that was at 1969, I think it was, came out. And then Frank Rosenblatt, who was the kind of the inventor of perceptrons and one of the key figures around at the time, he tragically died in a boating accident. I mean, really ridiculous. So you had three figures who could have really changed history. They all kind of exited the scene, and as a result, I think largely of that, neural networks were going nowhere. Anyway, in 2006, these characters get back together. There's Minsky in the center again, and there's John McCarthy. The survivors, as it were, got back together, and they all admitted that actually in the first 50 years, AI had got nowhere. They were going to solve the basic problems in 2 years. They had solved nothing, and they all predicted also that it probably wouldn't they wouldn't achieve very much in the next 50 years. But as it happens, and they weren't to know this, but there was a development happening roughly around 2006, the very time they were meeting up, that actually was to change the course of history. The discovery that GPUs, graphic processing units, were actually very effective in powering up computers and making them faster, along with a whole host of other things, the emergence of big data, cloud computing, and so on and so on and so on. And this led to the emergence of deep learning, which could be seen as a subset of machine learning, a subset of AI. Pretty much everything you've got today, ChatGPT and so on, Midjourney and whatever, it's all deep learning. It's all based on neural networks. I'm going to skip this section because this was an earlier section, but just to say that in the past, many years ago, I was working, along with many others actually, on swarm intelligence. When I was teaching at the AA, we were all reading Emergence. We were all reading Swarm Intelligence book coming out of Santa Fe Institute. And then subsequently, Roland Snooks and I published a book on swarm intelligence, which of course is a deeply kind of biological thing. This is it's based on complexity emerging out of simple rules. In this flock of birds, each bird is following a simple rule, keep going in broadly the same direction, the same speed as the birds around you, and keep a certain distance from all of them. But as it happens, out of that, the sum is greater than all the parts, and something emerges, some behavior emerges. Not that they're aware of it. As they're in their flock, all they see is the birds around them, but we can see it. Anyway, there's a lot of, this had a huge impact on architects. This is the work of Daniel Bolajan. And of course, at the same time, out of MIT, Casey Rees and Ben Fry were producing processing. This is not using processing. This is Daniel Bolajan's own stuff. He is now one of the leading people in the world of AI. And people like Roland Snooks were doing this kind of work that was quite interesting in a way, but just kind of in a way formal. It's all about generating forms. And of course, Roland himself is working on AI. This, if it's working, is meant to be the Tokyo. Let me try again. Oh, it's not really working. Let me just see if I can, or is it? Let me just that. This is a slime mold trying to work out the, it's not working. Anyway, it doesn't matter. But the point is, in the end, the real problems about swarm intelligence, it wasn't very intelligent. There are two terms. There's intelligence as a type and intelligence as a degree. How intelligent is it? Anyway, of course, there was this year, Colorati coined this term intelligens. I won't say too much about it, but I like this kind of comment that Venice itself is a living laboratory whose architecture and intelligence are tested in real time, while the Biennale itself becomes a living laboratory for experimentation and real-world testing of hybrid intelligences. He's talking about these three different types of intelligence: natural, artificial, and collective, and he coins the term gens, intelligens, from the Latin being the people for that. And then alongside that, we have Ethan Mollock, just publishing as well on co-intelligence. This, I think, is, I'm not going to talk about this today, but this is incredible. This is the impact of using ChatGPT. And this was not ChatGPT 5, it's like 3 or something, like 3.5. And the difference between the blue mountain, those not using AI, and the green mountain, those using AI, 40%. 40%, that is astonishing. I put this together a few minutes ago. I'm not quite sure you can see that, but imagine Usain Bolt running the 100 meters and being 40 meters ahead of everyone else. That's what we're talking about. That is astonishing. That would not happen. So that really puts it in perspective. Then there's Andy Clark, and I should also, I meant to put a slide in for our talker yesterday, bacteria to AI. So anyway, whatever. I'll move on because I don't want to talk about that today. There's not much time. But I want to look at the question about intelligence and prediction. And this is really engaging with the world of neuroscience. We had Carl Friston is one of the most cited neuroscientists in the world. He is astonishing. When we had him on Digital Futures, again, you can find that in our link. And just to say briefly what he is talking about, he's famous for the concept of free energy principle. Let me just read this out. Intelligence, both biological and artificial, is grounded in prediction. The term prediction is going to come up again and again and again and again. And that in order to stay alive, the brain's job is to minimize surprise through predictive modeling. Thus, biological systems such as the brain maintain their structure and function by minimizing free energy in order to reduce prediction error. This goes beyond mere perception so as to frame intelligence as minimizing surprise across all cognitive and behavioral domains. In other words, in order to minimize surprise, the brain must keep the world in line with its predictions and its predictions in line with the world. This guy is really smart. Also from Cambridge, the other Cambridge. And then of course Anil Seth himself. He's also been on Digital Futures, he's astonishing. Anil Seth is, I mentioned before, he did a PhD in AI. He's now at the University of Sussex, and Andy Clark moved down to Sussex to be with him because he's also interested in prediction. And he is hugely influenced by Friston, and his whole thesis is perception is a form of prediction, but it's based on a controlled hallucination. I love this, right? It's totally wacky stuff, but it's grounded in science. Anil Seth sees intelligence as inseparable from prediction. To be intelligent is to anticipate, to generate internal models that guide action and perception by reducing uncertainty about the world. Very, very similar to Carl Friston. This is his TED Talk. This is incredible, like 60 million, whatever it is, but really, really good TED Talk. And this is a clip from it, which I think Benaz might have shown us.
Sorry, I do need to put it on the audio. The audio is...
All I have to do now is keep adding stock and stirring it, massaging out all the starch until it's ready. Now, while that's just finishing off, here I've got some lovely wild mushrooms. I've got the Giraud, Pied de Mouton, Chanterelle with the mushroom.
The participants in our Zoom, if you can mute yourself, that would be great.
Saying basically the brain is locked into a bony skull, no light, no sound coming in, just these very imprecise electric signals, and it's trying to make sense of it by a form of prediction. Hallucination is an uncontrolled form of perception, and perception is a controlled form of hallucination. He has his book, also been hugely successful, just come out right now. Let me just make a short diversion, but to explore or at least follow up some of these ideas. And I want to refer to this guy, Memo Acton, really smart guy, now at the University of San Diego, friend of Benaz. Huh? Oh, he's incredible. And his sister's an architect, by the way. I met her in Turkey in the summer. What he's doing here is basically very close to what Anil Seth's doing. He's trained a neural network on various data, in this case, flowers, but also the ocean and also fire. And what he's basically saying is we are seeing it through the lens of what we have been trained on. We see the world through the lens on which we've been trained. We're not so different to neural networks. We've been trained, conditioned to see the world in a certain sort of way. So just an example of this, ask any school kid. Well, maybe I should ask you. Maybe I won't embarrass you by asking you, but how many colors are there in a rainbow? Everyone will say, all the kids say, please, sir, it's 7, red, blue, orange, indigo, violet. They all say that, right? That's nonsense, right? That's nonsense. We're trained to say that, we're trained to see these 7 colors in a rainbow, but anyone can see that a rainbow is an infinite spectrum of many, or every single color. There are an infinite number of colors in there. And similarly, one could say perhaps in architecture, this is maybe stretching it a bit, but functionalism, flat roofs, functional, we're trained to think that. So I want to come, this is a comment that this is my own personal interpretation of how we can see this and look at this. This is one of my students, FIU, who did an exercise very similar to Memo Acton, but he's using his clothes, his wardrobe. This is t-shirt, and on the right-hand side, trained through the lens of a data set based on a building by Zaha Hadid Architects, a research center in Saudi Arabia. And a t-shirt turns into a Zaha building in a way, which is astonishing in some senses. But so my question is this maybe how we, through our gaze, we begin to interpret the world, or this kind of generic downtown modernism in Miami downtown, where his tie becomes a tower block. This is an incredibly interesting exercise, right? So what does it mean? This is what I took from the window of a plane this summer when I was flying to Sydney to give some lectures. What I want to suggest is that maybe the way we operate as architects is that we are, in a sense, seeing things out there and then interpreting them through the lens of an architectural mind, turning whatever it is, elements in our environment into possible architectural forms, or at least imagining them as possible forms of architecture. And, so if you want to know the secret of this building, which is, to me, is very, very significant. I studied architecture because of that. I went to study in Cambridge, and in the era of postmodernism, got very disappointed because we weren't doing Sydney opera houses. But really, what's happening is that it's not kind of, this is something I did on Mid-Journey, right? This is not what happens, right? It's not as though it's born, as Alberti might say, conceived in the mind and realized through construction. It's not that. It's actually something that's filtered through from the environment around. We know from what Utzon said himself that he was very inspired by the billowing sails of yachts in the harbor and the kind of the monuments of Aztec Mexico led to inform the plinth itself. But I would claim that this idea of architecturalization, of translating things, or goes also into concepts. Deleuze and the fold, we automatically think that he's referring to forms, right? In fact, he's referring to subjective forms of the unconscious, but nonetheless, we to interpret it as fold. Interestingly, he had a huge following on the surfing community because the surfers also interpreted the fold as that. In fact, in my book, Rethinking Architecture, he refers to surfing to kind of respond to that. But and it also goes into I'm taking a swipe at the Bartlett now. Gilles Retzin, who sees the word discrete. The digital is discrete, and therefore he comes up with a form of discrete architecture. Or Mario Carpa, who reads that big data is messy, and therefore sees this 3D printed chair and interprets that as the example of big data, of the architecture of big data. What is the architecture of AI? There is no such thing as an architecture of AI. AI is about information rather than form. And the example I use to illustrate this is to say, think of an Uber car. Is that any different to an ordinary car? No, because it is an ordinary car. It's just operating in a different way. The way that it processes information is completely different. And I think the key driver of change in the cities of the future is not going to be form so much as information. AI-controlled traffic and so on and so on. And of course, the worst culprit in some sense, or the worst victim, was Derrida himself. Architects see the word deconstruction, automatically think he's talking about architecture. In fact, if you want to give an example of deconstruction, it's been like looking at the rainbow, and we've received this view that it's based on 7 colors. That's what needs to be dismantled, those preconceptions and so on. Anyway, I won't talk about that now because that's another subject. So neuroscience and spatial intelligence. This is another discussion that we had. Jeff Hawkins, super smart guy. He invented the Palm Pilot and now has he's kind of self-styled neuroscientist. And his project is to kind of reverse engineer the brain, which I think is probably a flawed project because not many other people are doing that. He's trying to understand the brain and then eventually build AI based on that. But so the two parts to his premise. One is that it's really about the neocortex, and there are these. He sees the neocortex as based on many different columns, hence 1,000 brains. And what happens in this 1,000 brain theory is they all form an opinion, and by consensus they eventually vote on what they think is happening, and so on and so on and so on. It's like a democratic consensus among many mini brains. But what I'm interested in more is his understanding of spatial intelligence, which is incredibly architectural. So maybe I'll read this out. Meanwhile, intelligence arises from embodied interaction with the environment, predicting what will be sensed next based on movement, predicting what will be sensed next. It depends on our ability to predict how the world will look, feel, and sound as we move through it. Intelligence is therefore rooted in the brain anatomy and physiology, while prediction is embodied, spatial, and rooted in biological evolution. As such, Hawkins's model of prediction is deeply spatial and in many respects, architectural in nature. Okay. So it's also location-based. So you're anchored almost like in a grid. Just how a building's spaces are defined in relation to a floor plan or grid. Likewise, each cortical column operates in its own reference plane, allowing us to understand not only what the objects is, but how its parts relate to another in space. This allows it to build a kind of mental architecture of objects and environments. In other words, Hawkins' theory of the brain suggests that intelligence is not just about logical inference or symbolic manipulation, but also about constructing and traversing internal models of space. We've got a model of the world outside in our brain, much like how an architect designs, imagines, and mentally moves through a building. As such, it treats intelligence as a process of constructing, updating, and navigating 3D predictive models. It is almost as though Hawkins is proposing a neural architecture of architecture, a theory of mind in which to know is to build and inhabit spatial models. I think there's enormous potential to explore that. But I think he's flawed in his idea that we can therefore just build AI. He's not working through the LLM logic to get there. So then looking at AI, and this woman, Fei Li, what a rock star. I mean, she ought to be the one to get the next Nobel Prize. Absolute genius. She's originally from China. She's now got her World Lab, I think it's called, where she's working on spatial intelligence. But importantly, she was the one who recognized very early on the role of images. She put together this ImageNet database of 15 million, I think it was, images. And let's hear her talk.
The ability to see is thought to have ushered in Cambrian explosion, a period in which a huge variety of animal species entered fossil records. What began as a passive experience, the simple act of letting light in, soon became far more active. The nervous system began to evolve. Sight turning to insight. Seeing become understanding. Understanding led to actions, and all of these give rise to intelligence. Today, we're no longer satisfied with just nature's gift of visual intelligence. Curiosity urges us to create machines to see just as intelligently as we can, if not better. 9 years ago on the stage, I delivered an early progress report on computer vision, a subfield of artificial intelligence. 3 powerful forces converged for the first time. A family of algorithms called neural network, fast, specialized hardware called graphic processing units, or GPUs, and big data, like the 15 million images that my lab spent years curating called ImageNet. Together, they ushered in the age of modern AI. We've come a long way. Back then, just putting labels on images were a big breakthrough. But the speed and accuracy of these algorithms just improved rapidly. At the annual ImageNet Challenge led by my lab gauged the performance of these progress. And on this plot, you're seeing the annual improvement and milestone models. We went a step further and created algorithms that can segment objects or predict the dynamic relationships among them in these works done by my students and collaborators. And there's more. Recall last time I showed you the first computer vision algorithm that can describe a photo in human natural language. That was work done with my brilliant former student, Andre Kapathy. At that time, I pushed my luck and said, Andre, can we make computers to do the reverse? And Andre said, haha, that's impossible. Well, as you can see from this post recently, the impossible has become possible. That's thanks to a family of diffusion models that powers today's generative AI algorithm, which can take a human prompted sentence and turn them into photos and videos of something that's entirely new. Many of you have seen.
I want to just quickly point out what happened after that. So Geoffrey Hinton, I mentioned earlier, right? He came along with his team, they had a neural network called AlexNet. Ilya Sutskever and a Russian PhD student called Alex, I forget his name, were part of that team. And you've got to understand that neural networks at that time was seen as some sort of obsolete technology, like a steam engine, right? But this was the moment they came in, and this was, 2006, I mentioned when they got back together. This 2012 is when it hit home, when suddenly people began to realize what neural networks could do. And this was it. I mean, this is a neural network. These are called neurons. These are the synapses, and the flow of information from left to right is based on the weights on the synapses. And what's happening is that the pixels of this image here are being processed through the hidden layers. There are anything up to 5,000 hidden layers, hence the term deep learning. And eventually it comes out with the conclusion, bird. Never 100% sure, normally 99% sure, but a bird comes out. Anyway, Hinton's team thrashed the opposition, and everyone was completely blown away by this. Fei-Fei Li in her autobiography, she's probably exaggerating, right? She says it was like the world speed record was beaten for a car, was beaten by 100 miles an hour by someone driving a Honda Civic. Well, I'm not sure about that, but anyway, it was a complete revelation. And overnight, everyone changed tune and said, oh, of course, I always thought that neural networks are the way forward, right? But what the real holy grail for the world of computation was not to recognize an image. And just to remember, in 2012, we had none of this. We didn't have facial recognition on our cameras or anything like this. But it was to go the opposite, to generate an image, to hallucinate an image, to synthesize an image, to go from bird to the image. And eventually they realized that, and I won't go into this in detail, that you can invert the network. Alex Morvincev produced what's called Deep Dream, this very trippy thing that, of course, that Anna Seth had referred to. Then Ian Goodfellow came along with GAN's generative adversarial networks. I won't explain these, but they rely on two different neural networks competing against each other, adversarial networks, and very hard to put together, very laborious. You've got to train them yourself and whatever. But it did produce a remarkable better production. I've got a slide out of place here, but let me just skip. So meanwhile, in architecture, we were way behind. This is 2019, right? And I put together a team with Zahidid Architects, with Refik Anadol, sponsored by Google, with a bunch of other people. It was a dream team. It was a dream team. We were proposing to curate the British Pavilion and point out that out of that legacy, this had potential to be used in architecture, and we weren't even shortlisted. We were not even shortlisted. In 2019, nobody was even thinking about AI. But what Refik did was basically do what we were planning to do. In other words, not to hallucinate, synthesize images of people, but to generate images of an architectural design. So he went ahead, and he'd been trained by Blaise Guiriakos's group, the Artist Machine Intelligence group at Google. He did a projection onto the Frank Gehry Opera House in the concert hall in LA. They helped him, and he learned how to do this. And eventually, with his own form of style GAN, he eventually begins to produce something that is kind of vaguely recognizably Zaha-like. And this is the first GAN-generated image, I think. That went on the cover of my book, came out in December 2019. Meanwhile, other people, this is Daniel Bolajan using cycle GANs, two unpaired neural networks playing off against each other, breeding effectively outcomes. This is the work of Cole Pimmelblau plus geological formations. And it kind of produced something that at the time was really state of the art. pretty extraordinary, you thought. And that was the kind of stuff that came out. And we put this on the cover of what was, I think, the third or fourth book on AI to come out, an architecture, in early 2022. There was a slew of 6 books, and they were all out of date by mid 2022 because we had a new technique. In fact, I was talking about this in the AA, a lecture at the AA, diffusion model. I mean, we all know about this now, but this one's quite interesting because the prompt is an astronaut on the horse, and presumably there's never been an astronaut on a horse, and therefore it's able to interpolate. AI doesn't copy. There's a false presumption that it copies. It does not copy, and this is an indication of that. Anyway, I was talking about this at the AA, and I was saying, when will architects wake up to this? And then there was a voice in the audience that said, we already have. I didn't realize it was Patrick Schumacher. And he'd been working with Refik because Refik had been given access to DALL-E 2. DALL-E 2 was not released until much later in the year. And they produced this. So Refik was responsible both for the first ever GAN and the first ever diffusion model image of architecture. Then later on, we went from text to image, text to video. This is Sora. OpenAI has the habit of announcing something and not releasing it to all the competitors have caught up. So they announced it, I think it was in February, and didn't release it till December. Meantime, Runway and others had done this. We had text to video from late 2022, but nothing quite like this. The fact that the consistency, they could keep it going for 60 seconds, and the resolution, the degree of detail, and you soon see a close-up of this face, was really, truly phenomenal. Nothing that we had expected. Anyway, and of course, then we all did that. This is art galleries that I generated using Runway. I mean, I was astonished by this. I thought 2024, I couldn't believe we were doing this at that time. You know, it just seems so, but it works the same way. The text to image pairs text and image up via captions on the web, and this works exactly the same way. So you could do it with anything, with music, with videos, with whatever. And it knows how to design. This is an important thing. It knows the proportions. It's learnt that from the data set. These are pretty sophisticated things. Anyway, so my book was out of date, so I produced this other one, endorsed by Refik and God knows who else, dealing basically with videos, with ChatGPT, which I think is hugely significant. Maybe I'll get a chance to talk about that. Anyway, so I should say that when I first started writing my first book, I forgot to mention this, I was a little unnerved by this, by the fact that it was both amazing and terrifying. I mean, I'm amazed every day by AI, but also terrified every day. So I said to Bloomsbury, I said, I feel compromised. This is incredible, but it's also terrifying. Can I do 2 books? Can I do one with a white cover, like The Angel, the good side of AI, and one with a black cover, like The Devil, the dark mirror, the black mirror episode of AI? And they agreed. So this was so we're working our way through. This is the version of the white one. We're going through pastel colors, and then eventually, and then we're going to with black, and then we're probably get merge in the middle eventually with gray. So anyway, AI and going back to Fei-Fei Li. So she had initiated the whole thing, all that stuff that we know from Midjourney comes from Fei-Fei Li, ultimately, with the intervention of Geoffrey Hinton.
I'd like to add to that. Simply seeing is not enough. Seeing is for doing and learning. When we act upon this world in 3D space and time, we learn and we learn to see and do better. Nature has created this virtuous cycle of seeing and doing, powered by spatial intelligence. To illustrate to you what your spatial intelligence is doing constantly, look at this picture. Raise your hand if you feel like you want to do something. In the last split of a second, your brain looked at the geometry of this glass, its place in 3D space, its relationship with the table, the cat, and everything else, and you can predict what's going to happen next.
Okay. So basically, she's moving from 2D to 3D, and one can assume that if 2D led to sort of GANs and whatever else, and image generation, that hopefully something will come out of the 3D wise out of this logic.
Imagine patients with severe paralysis controlling robots with their thoughts. That's right, brainwaves, to perform everyday tasks that you and I take for granted. You're seeing a glimpse of that future in this pilot study from my lab recently. In this video, the robotic arm is cooking a Japanese sukiyaki meal controlled only by the brain electrical signal, non-invasively collected through an EEG cap. The emergence of vision 500 million years ago turned a world of darkness upside down. It set off the most profound evolutionary process, the development of intelligence in animal world. AI's breathtaking progress in the last decade is just as astounding. But I believe the full potential of this digital Cambrian explosion won't be fully realized until we power our computers and robots with spatial intelligence, just like what nature did to all of us. It's exciting time to teach our digital companion to learn to reason and to interact with this beautiful 3D space we call home, and also create many more new worlds that we can all explore. To realize this future won't be easy. It requires all of us to take thoughtful steps and develop technologies that always put humans in the center. But if we do this right, the computers and robots powered by spatial intelligence will not only be useful tools, but also trusted partners to enhance and augment our productivity and humanity while respecting our individual dignity and lifting our collective prosperity. What excites me the most in the future is a future in which that AI grows more perceptive, insightful, and spatially aware, and they join us on our quest to always pursue a better way to make a better world. Thank you.
So the real challenge of this is that for large language models, it's easy enough to scrape the data off the internet, the images and text and so on. It's there. The trouble is about 3D data is that we've got it, right? What we're doing the whole time, we've trained ourselves on this, and over time, we know exactly what things should look like by what we've seen before. We know what it should look like when someone throws, I don't know, a stone into a pebble into a pond. We know what the ripples should look like, and so on and so on and so on. But where do you get that from? And you can't scrape it from the internet. So it means basically you have to fabricate it synthetically. You do it in simulation, therefore you can speed up the process, but it's still a very long, laborious process. Anyway, I think what I'm basically saying is that she, and she's set up this company, World Labs, she saw the relevance of 2D and was instrumental in opening up that area, and she's now seeing the relevance of 3D. She's not the only one, right? NVIDIA and lots of other companies are looking at it, but the reason why this is so important is frankly, we're moving into an age of domestic robots that need to be trained and trained and trained. You've probably seen on Instagram the Olympics for robots, which is a complete joke. They're all falling over. That's because they haven't been trained enough. But that's part of it. This is the world that we're entering, and we're also this is from Venice. I took a Waymo. Unbelievable! It's really the future. It's astonishing, and it's kind of weird because there's no one in the driving seat, but it's so careful about how it drives. I was really stunned by it. And so this is what's coming on stream. And this time next year, this will be nothing special. They'll be all over the place. And what it's doing, you can see that dashboard there where it's kind of steering the wheel. I don't know why you don't use the passenger seat. I think there must be regulations. You've got to have a wheel or something. I don't know why they don't get rid of that, but anyway, they do. It's basically visualizing this with using LiDAR, and as it goes along, it's kind of interesting when you could see what it does. Very sensitive. This is a different technique to what Tesla are using. So there you can see, that's what it's looking at, right? These are the cars and things, it's 3D modeling of those things. Anyway, so that's why we need spatial intelligence. This is what we're about. I want to move on to this other guy, Blaise Agiriakos, who has been here. Absolute genius, absolute genius. We've had him on Digital Futures several times. Incredible. He's going to be on next semester. And of course, his book, if you haven't got this book, buy it. MIT Press, What is Intelligence? One of the most unbelievable books I've ever come across. And part of it is about, essentially, he's got this view that life is computational. I'm not going to talk into that now, but there are some very interesting, that's what his thesis is. But alongside that, he talks about the nature of intelligence itself. So let's just hear Blaise talking about that.
So something really did happen around 2020. I'm using round numbers. There's not a specific paper, there's not a specific model. But essentially, it was the rise of unsupervised learning. So this was the period when we went from training neural nets to reproduce specific and task-specific types of inputs to training them to predict the future. And the form of that kind of future prediction initially was text. So you have lots of text that's straight from the internet, and the past is text so far, and the future is next token, next piece of text, next word. Then training the neural net on that task, interestingly, was what led to AGI. Now that's a little bit puzzling, actually. That's a little bit puzzling because you might think, how could it possibly be that autocomplete could result in general intelligence? My good friend Ted Chiang, has castigated this approach to AGI as being like autocomplete, and he's right. I think that he's just underestimating what autocomplete means. So to give a little bit more color, my team of people worked on the autocomplete problem, on the unsupervised text prediction problem for quite a few years in the context of small models that were supposed to run on phones. So we built a lot of new AI that got built into Android and Pixel. And one of those pieces of AI was the next word predictor in the keyboard. So you used an Android, or I think iPhones have more or less the same thing. As you're typing, there are predictions of possible next words that show up in that strip of the keyboard. And we did it, of course, because it's a pain to type with two fingers on a keyboard, and the better we can predict what the next word is likely to be, the faster you can type. So it's just a very simple pragmatic sort of thing. But our impression was that building our machine learning models to predict the next word would never, the result would always be mediocre. It would always suck. And the reason we thought that is because the problem of predicting the next word is AI complete, meaning that it's sort of like a thread that you pull on a sweater that ends up unraveling the entire sweater. At first it looks like an easy problem. The first word is Humpty, the next word is going to be Dumpty. If it's Helter, the next word is going to be Skelter. And you can get those kinds of statistical regularities just by making a histogram of next words, even previous words. But if the previous words have been a word problem, and the next word is supposed to be the answer to the word problem, then suddenly the model, or whatever it is, right, that is behind that prediction, has to be smart enough to actually understand math and be able to reconstruct the word problem and do the problem. If it's a story and the next word says how a certain person in that story feels, then whatever's predicting the next word has to not only have followed the story and understood the characters in it, but even be able to put themselves in place of one of those people and use theory of mind in order to understand what that emotion is. So when we're talking about word problems, math, theory of mind, having a clever idea or understanding a tongue or a joke, we're now in the realm of general intelligence. I heard a very disappointing thing from John Oliver, who I generally love, years ago when these models first started to go on the market, in which he said, don't worry, it's just, this isn't artificial general intelligence. All it's doing is emitting text. And yes, those early models were just predicting text tokens, but that's what I mean. If the idea is that intelligence can't be general if it's only transacted in language, I think that's a crazy idea. Language is fully general, and it is fully capable of expressing an enormous range of human abilities and intelligence. I don't want to bring ability studies into this, but Stephen Hawking lived most of his life with purely textual output, and he was able to have an enormous influence on culture, interacting in very rich ways with lots of people, essentially just using language, using a form of language in this case that was based on a very low bit rate sort of output for this body. So it's not about the medium. It's about what is in it, if that makes sense. Anyway, so my position and Peter's was that when we developed unsupervised sequence prediction and it began to actually solve important problems, we started to have conversations with we saw we had generality. Doesn't mean it's reliable yet, doesn't mean it's technologically useful yet, but we have it. I noticed that we've had Carl Friston on. He was actually hypothesized for a long time that prediction of the future given the past is sort of the key to what intelligence is. I didn't necessarily believe that before this whole unsupervised learning revolution, but now I do. I think the proof is in the pudding when we start to use very general models to the future given the past, and when applying that to language generated something that was fully general in all of these ways. I think it was a great indication of the point that Friston was making. And he wasn't the first to make it. Arguably, Helmholtz in the 19th century talked about intelligence that way in terms of prediction of the future in the past, and perhaps it was further back.
So, I mean, I'm going to skip that one because, but what he's saying basically, intelligence is about prediction, and that comment going back to Friston was really what sparked off this particular presentation, trying to connect the world of neuroscience with the world of AI, especially in terms of spatial intelligence. Let me just.
I forgot to mention, your two books will be sent without the question mark and who are we now with the question mark. You have this book on the coming up next year. Could you give us a brief kind of paraphrase about what it's about? We had Jeff Hawkins on here a couple of years ago talking about this book on intelligence. How do you do that from him? How do you approach it?
Well, yeah. So the book is called "What is Intelligence," and it actually has a sort of it's part one. We've turned into a little limited edition book that we're actually holding next week. So we'll give it away to attendees at the launch event in MIT. And the little one is called "What is Life?" After Schrodinger's book, "What is Life?" in the 1940s. So the two are connected issues, as I just described. So part one of the book is about this abiogenesis work. The rest of it goes into all of these questions about intelligence, theory of mind, etc. I guess the most succinct way of talking about it is would be with the definitions that I use. So the definitions are: life is the computational phase of matter arising from evolutionary selection for dynamic stability, and intelligence is the ability to model, predict, and influence one's future, evolving in relation to other intelligences to create a larger symbiotic intelligence. So they both have a multi-scale property, and the two definitions are highly powered.
It sounds like that Hitchhiker's is trying to galaxy kind of the world in the is not so far off the market.
No, I think Douglas Adams was right about even more than he realized he was right about, which probably was already more than the rest of us.
Douglas. Douglas Adams was at Cambridge too, as was Stephen Hawking. So AGI, the other part, I'm just going to touch on this briefly, but this is the other side. What level of intelligence? So with these large language models, there's been speculation. When I wrote my first book, there were people who, Rodney Brooks was saying, we're not going to get it till 2099. And now we're thinking, holy shit, this thing is going better than we thought. And anyway, so it's a big question about whether we're there or not. Blaise believes we are already in the early stages of AGI. Now, let me just explain through analogy with a plane. Birds fly. Planes also fly. They fly in different ways. A bird is a biological entity. A plane is a mechanical device. But they both fly. The same goes for intelligence. The brain is intelligent. It's a biological organism. It's intelligent. But so too is AI. They're a different form of intelligence. One's biological, one's mechanical, but they are both forms of intelligence. And intelligence can operate on different substrates. Now, the point is, once, and going back to the flight analogy, once the Wright brothers had got this thing to fly, to take off, the rest is history. That's why he's saying we're at the early stages of AGI. Well, of course, what's happening now is that everyone's interested in artificial superintelligence, not AGI. And whereas AGI was kind of, matching the average human being, this is like producing an entity that is smarter than Einstein, and so on and so on. I won't go into that now, but the race is on. Everybody's charging ahead, trying to poach other people from other people at companies without any disregard for energy or anything else. The race is on. So this is just a brief comparison with these three figures. I think they're very interesting in their own right. Hawkins is kind of doing neuroscience at the moment, whereas Blaise is doing AI. While both Blaise and Hawkins ground their theories of intelligence in prediction, their frameworks diverge significantly. Whereas for Blaise, prediction equals intelligence, for Hawkins, intelligence means sensory motor prediction. Whereas Blaise focuses on computational and philosophical questions, Hawkins focuses on neuroscience and the anatomy. Whereas for Blaise, the substrate can be either biological or computational. For Hawkins, it is primarily biological. Whereas for Blaise, embodiment is required. For Hawkins, it is essential. Whereas for Blaise, LLMs are intelligence. For Hawkins, I should revise this because I heard him say they're absolutely not intelligence. Whereas Blaise prefers to work with large-scale neural networks, Hawkins prefers to work with the cortical column-based systems. But perhaps most importantly, Hawkins is operating as a neuroscientist starting from biology and trying to understand how the brain works, whereas Blaise is operating as an AI researcher, starting from computation and trying to understand how AI might achieve intelligence. And then Fei-Fei Li, to some extent, Fei-Fei's position can be seen as a compromise between the two. Like Hawkins, she sees spatial modeling at the heart of intelligence. Like Hawkins, she believes that true understanding arises from interaction with the physical world. Like Hawkins, she is interested in constructing internal models of the external world. Like Hawkins, she rejects the idea that intelligence can emerge purely from text-based models. The only significant difference is that whereas Hawkins seeks to understand how the brain generates intelligence through spatial prediction, she seeks to build intelligent systems that can do the same in artificial form. Similarly, like Arcus, she treats the prediction as the foundational computational principle of intelligence. Like Blaise, she sees deep learning and self-organizing networks as necessary foundations for building intelligence. In short, both recognize that intelligence arises from the ability to model and predict the world. It's just that whereas Arcus expresses this through linguistic, recursive, and self-reflexive modeling, she expresses it through spatial interaction. So there's a deep difference between these two. I see it, it's in terms of Moravec's paradox, the idea that what we're good at, like catching bulls, AI-controlled robots are useless at, and what AI-controlled AIAC is good at, like the fact that ChatGPT knows 10,000 times more than any of us. So there's a difference. So on the one hand, you except they're learning how to catch bulls. Right? This is the Tesla. Oh, this might look like an ordinary cat. That's very significant, right? And I guess the other thing about OpenAI, and I've written a lot about this. The launch of ChatGPT was a stunning moment. But the perverse thing is that actually OpenAI had no clue what it was going to lead to. They were, at the time, November 2022, they were working on GPT-4, and it was spewing out hate speech because it's trained on human data, and we spew out hate speech, so you have to go and tidy it out. So that wasn't ready to be released. Meanwhile, all their competitors were releasing something. So they said, well, we've got to go and do something. So halfway through the month, 15th of November, they said, okay, let's go and produce, I think they call it a chatterbot, first of all. So they took GPT 3.5, kind of put on this ready-made scaffolding they've already done and produced this thing. And the way they put it was just amazing. They said, oh, this is no big deal. This is just an internal research preview. We just want to test out the market. They had no clue. Well, the thing about this, what is so astonishing about this, and this is a whole lecture in itself, are the weird things that it can do that it was never trained to do. It's learned how to code. It's learned how to translate languages. No one trained it to do that. It simply searched through patterns in the data and figured it out for itself. And that is astonishing. I've also noticed this in terms of what we can do with, this is just Mid-Journey. It's capable of a thing called occlusion. Now, occlusion is basically when something disappears off the frame and comes back into it, or hides behind something and comes back into it. And this is something that again, it wasn't trained to do, but it's kind of figured out from the data how things happen. Maybe let's leave it on for a bit longer because there's a better form of occlusion just coming up when it's just simply completely hidden behind things. You'll also notice it knows how to step down as well. And so these are kind of uncanny in some senses and unnerving. At some point, the Future of Life Institute, led by like Max Tegmark, also at MIT, said, listen, we've got to slow this down. You know, we've got to, they issued this letter saying, please stop developing these large language models bigger than GPT-4 until we know what the hell's going on. That was a complete failure. Elon Musk, everyone signed it, and no one did anything. It's a bit like asking the leader in the Boston Marathon to slow down. Are they going to slow down? No, because the competitors are going to catch up. So it was a complete failure. And as a result, Elon Musk jumps ship and goes, okay, I'm going to go and produce super intelligence, and so on and so on. But this is a kind of interesting how it's learned to walk up steps. Now, if you think about it, there's no eyesight. It's simply learning like we have learned to know what it looks like for people to walk up steps. Here we go. That might just look like someone walking up some steps, but that is pretty amazing. Now, I want to just move on to this latest thing, Genie 3, and Demis Hassabis talking about how it's learned to intuitively reverse engineer the world.
World that we're seeing. So you're seeing someone actually can control the video. It's not static video, it's just being generated by a text prompt. And then people are able to control the 3D environment using the arrow keys and the spacebar. So everything you're seeing here is being all these pixels are being generated on the fly. They don't exist until the player or the person interacts with it goes to that part of the world. So all of this richness, and then you'll see in a second. So this is fully generated. It's not a real video. This is generated someone painting their room, and they're painting some stuff on the wall. And then the player is going to look to the right and then look back. So now this part of the world didn't exist before, so now it exists. And then they look back and they see the same painting marks they left just earlier. And again, this is every pixel you can see is fully generated. And then you can type things like person in a chicken suit or jet ski, and it will just in real time include them in the scene. So I think it's quite mind-blowing, really. But I think what's hard to grok when looking at this, because we've all played video games that have a 3D element to them when you're in an immersive world. Yeah. But there's no objects that have been created. There's no rendering engine. You're not using Unity or Unreal, which are the 3D rendering engines. Yeah. This is actually just 2D images that are being rendered, like
created on the fly by the AI. This model is reverse engineering intuitive physics. So, it's watched many millions of videos and YouTube videos and other things about the world. And just from that, it's kind of reverse engineered how a lot of the world works. It's not perfect yet, but it can generate a consistent minute or two of interaction as you as the user in many, many different worlds. There's some videos later on where you can control, a dog on a beach or a jellyfish, or that's not limited to just human things.
Because the way a 3D rendering engine works is you type in, the programmer programs all the laws of physics. How does light reflect off of an object? You create a 3D object, light reflects off, and then, so what I see visually is rendered by the software because it's got all the programming on how to create physics, how to do physics. But this was just trained off of video and it figured it all out.
Yeah, it was trained off of video and some synthetic data from game engines. And it's just reverse engineered it. And for me, it's very close to my heart, this project, but it's also quite mind-blowing because in the 90s, in my early career, I used to write video games and AI to video games and graphics engines. And I remember how hard it was to do this by hand, program all the polygons and the physics engines. And it's amazing to just see this do it effortlessly. All of the reflections on the water and the way materials flow and objects behave. And it's just doing that all out of the box.
I think it's hard to describe like how much.
So what I want to suggest here is that you've got a sense of how the world looks like. As it gets more and more refined, my question is, do we need to make a 3D model of the world? Do we need to make that? I don't think we'll have a, I don't think we do. So finally, I'm going to finish off. Can AI become a mirror in which to understand human intelligence? I'll just simply mention that Craig Reynolds, when he produced these boids, nobody had understood how birds flock before. And the biologists found out, the ornithologists found out from that. Likewise, I swear, this is my favorite movie, right? One of the comments that Rutger Hauer makes is that Blade Runner was not about replicants. It is what it means to be human. This is Rutger Hauer.
Okay.
Oh.
It's okay. Yeah.
I've got one more slide for you, Hitoshi, just the next one. Amazing movie. So this must be a friend of yours, Hiroshi Ishiguro. I mean, I'm not telling you which one he is. He's either one on the right or on the left, but he does make this comment. The robot is a kind of mirror that reflects humanity, and by creating intelligent robots, we can open up opportunities to contemplate what it means to be human. Also, last week we had Stephen Wolfram talking about, he has a book about the ChatGPT. One of the comments he makes is really interesting. He says, basically, ChatGPT tells us that the language is not that complicated. And he says the same thing applies to Midjourney. It tells us that designing things are not that complicated. So I'll finish off with this. And I just think that spatial intelligence is what we should be focusing on right now. We live in an era of robots, in an era of self-driving cars. And I think the video game system, is going to surprise us. I think this intuitive physics are going to explain everything, and we might not have to 3D model everything. I don't know. But we're on the cusp of a very interesting moment, I think, in world history. So Okay, I'll finish it there. So, yeah.
Amazing. Thank you so much. Maybe we have a few minutes for any questions, comments.
Or you can send them to me on Instagram if you, whatever.
There are a few. Simon,
Yeah, I had a quick
do you have
question.
time?
Yes, yeah.
So we talked a bit about how intelligence is defined as sort of this mitigation of uncertainty. The more that we're able to sort of be able to computationally understand our perceptions, the more we're able to create more accurate hallucinations, I guess. I'm really curious because human perception is so much, has so many modalities. So we start with visual, we have audio, we have text, we have spatial now as well. Do you predict or do you imagine that we'll be able to sort of quantify or computationally translate all the modalities of interaction? Do you think we'll get there? Is there risk to doing that? I mean, I'm just imagining like when I'm having a conversation with a friend or with my mom, I can look at her and look in her eyes and I know exactly what she's thinking. Will we get to that level of perception of that type of accuracy or intelligence in machines?
Yes. I mean, Bernard's, I think, was come up the same. I don't know actually whether you'd think the same. But no, I don't underestimate these things. But I think one of the points is that the speed at which they're developing is way faster than us, right? I mean, I didn't talk about today, but one of the things I showed in this, when I was talking about AlphaGo Zero, it learned to play Go on its own by reinforcement learning, by playing 4.9 million games of Go over 3 days. If you work that out, that is 20 games of Go per second. That is astonishing. And I think the point that Geoffrey Hinton makes is that kind of when they learn, they share information with 1,000 other computers. So that we don't do that. And that's why, I think at the moment we're roughly at the same kind of stage, but it's going to not take too long before it's going to be racing ahead. So no, but I have no doubt that it will be there. What is interesting though is really for me, I guess I come from a kind of theoretical background. I'm really interested in what it says about us, the mirror of us, and I think that what we're seeing is this basically we have this incredible spatial intelligence. It's a remarkable thing because if something happens, if someone drops a stone in a bit of water and it doesn't ripple in the right way, we say that's not right. We know exactly, we've got a model of the world in our brain. And if you color your hair pink tomorrow, everyone will say you color your hair pink because we remember, everything. It's an astonishing kind of simulacrum of the world. So, but we've been trained because a kid, you could see it putting its spoon, in the wrong place kind of thing when it starts off. It's a bit like what robots are doing now. But they're going to get to the point where they're going to be so sophisticated just by training, So I think we really do understand a lot about ourselves in the mirror of AI. And the point being, if AI is modeled on the neural networks of the brain loosely, then the question is, well, what can we learn about our own brains in the mirror of AI? There's one thing I didn't really mention, but it's kind of weird, slightly disappointing aspect of what Blaise is talking about, and not in that particular lecture, but he's given a lecture when he launched the book last week, and he kind of believed in this biological thing, where I start off by saying, well, okay, that point of rupture where symbolic AI distanced itself from cybernetics was really a problem, really a problem. And actually, we've learned a lot through the biological model since then. But there's one point where Blaise says, yeah, well, I thought that, and I thought when it came to scaling up, because what's interesting about these large language models is that the computationally, they're not so sophisticated. They're just based on 200 lines of code. But as you scale up, they start doing these weird things. And he said, yeah, I thought it would be biological, but it seems that it's just straight scaling up. And I kind of think, well, but maybe there's a biological reason why the scaling up does it. I don't know. But, so that's the only disappointment I've got with that, because I completely believe in this kind of neuro-computational sort of view of the world. Yeah.
Thanks, Neil. My question is, why do you think a lot of these breakthroughs revolve around games, whether it's AlphaGo or like Deep Blue's chess victory? Right?
Yeah.
And now
Well,
we're getting to game engines.
Yeah.
Is play like the common language between AI and humans? Do you think that is
Um,
these threats happen?
It's actually, I mean, I think it's particularly about Demis So he was a chess prodigy when he was like 14 years old or something. So, you know, but I mean, but I guess it was something also Alan Turing was talking about it. So he wasn't necessarily, and we saw that photograph of John McCarthy as well. So I guess what the point is, it's a way of testing it out, first of all. But that's what I thought was astonishing, that when they were working on AlphaGo, they were saying, well, actually, we're not interested in this. We're interested in what you can do with it. And AlphaFold, a Nobel Prize, for goodness sake, you know, that came out of that. So I think there are probably reasons why it's quite easy to model on a game that makes it that useful. But in Demis's case, he literally was, and he then went into gaming. I think he mentioned that on the video. He was designing games. But that's a good question. I don't know whether we can push that further than that, yeah, it's a competition going on, right? And I think GAN is also about competition as well. So I think a lot of this, I mean, actually the history of AI is a history of competition. It's kind of, you know, symbolic AI versus neural networks. It's kind of, and now there's a whole space race going on. You know, it's literally what used to be the space race. It all started actually in 1957, because 1957 was when the Sputnik went off and shocked America, and that led to the foundation of NASA. Well, 57 was, and 56 was AI the first year. And then when AlphaGo worked for the Go playing nations, that was described by Kai-Fu Lee as being the Sputnik moment. And that's when he took off. So, and now, of course, the ultimate Sputnik moment was DeepSeek, which actually wasn't in my book because it came out a week after I submitted the manuscript, but DeepSeek really shocked America. And so it's all about a competition. The race is on. It's like AI is the new space race. Yeah.
So I actually started out like many designers like me are increasingly working with AI models. But I'm just curious, like if architecture turns perception into build form, then how should offices and studios redesign their design workflow and matrix and treat maybe hallucination as a control or design variable? Or should we actually embody hallucination as a design variable?
Well, in general terms, but that was what we spoke about on Saturday in Digital Futures. We had Tim Fu, Mariana Cabuchera, who was both ex-AA, ex-Zaha Hadid architects, and they've got new offices, totally pioneering AI workflow. And I put them alongside Lorena Knežević, who's working for Gensler. And there's, you know, it's not just about how you get new practices, it's how existing practices reconfigure themselves to deal with these things. And it's actually a really interesting session, so I'd look at that. In terms of hallucinations, I mean, there's a lot of stuff now on why do these things hallucinate, and part of the problem, you know, well, we used the term hallucination before it had a pejorative connotation. Machine hallucination was a title for the AD in 2022, but now has a very negative one. And apparently they've worked out that it's certainly in terms of ChatGPT, it's because it wants to please you. It wants to give you something, you know, even though it doesn't know, it just kind of throws something out. But, you know, I think hallucinations are actually quite interesting in themselves. So I'm not sure whether they're a good or a bad thing. But I mean, the whole thing ultimately is about control. Do you want to control it? And there are people like, we had, blanking his name now, from Singapore, Carlos Banyon, trying to show us how you could use ControlNet to control AI, or do you just allow it to do these crazy things and feed off it what it's doing? I actually think that the what's going to happen in the office is probably going to be something very, very different. I mean, I think that so I had three practices I look at in here. One of them being Foster and Partners, and Foster and Partners are not interested in ideation, not interested in using these mid-journey. We could design, we don't interested in that, but what they're interested in is surrogate models and ways of speeding up the production. And that, I think, is going to be the crucial thing, is the speed of production. Already we've seen that study I showed you showed that they could 25% faster. And of course, as the technology improves, so you can speed things up. I think this is one of the interesting, is the important things. And there's Wan Yu He from X-Cool, They did a series of hotels during COVID that they designed and constructed, completed within 16 weeks. That's astonishing, because if you're a hotel owner, every night you're not renting out your rooms, you're losing money. So I think the real driver of change is probably going to be speed rather than coming up with alternative ideas. In fact, what's interesting is that I also didn't show that slide today, but the recent research coming out of the other place over there, Harvard, was that that actually what people are using ChatGPT for, last year it was about generating ideas. This year it's about companionship. It's really weird. We live in the age of her, right? That's the kind of incredible thing.
Thank you.
Oh, thank you. Yeah, hi.
Hi, thank you so much, Neil. This is fascinating. My name is Alice. I'm also pursuing my master of architecture here at MIT, and like the use of AI as like a means of visualization is very, very interesting. However, I'm wondering what like things like Midjourney use to train themselves and to learn from, because like looking at this visualization, for example, to me it's quite scary because it's like this perfectly pristine, uninhabitable space filled with like thin women in high heels with no faces. How, like, what are the inherent biases of these visualizations?
Well, I mean, it's because of the prompt. I said make it clean and empty and minimal, so it's probably because of me.
But still, but like the fact that it uses like these like placeholder women as characters is like still it reveals something, no?
You could get a completely grungy, messy, whatever if you just change the prompt. Yeah, I'm to blame. Blame me, right? But no, and I wasn't expecting to walk up the steps. That was a shock when it came to me. You know? And that's again, it's just it's. I think this should go together with that Genie 3 thing. That the comments they made, that it's figuring out what's going on. It's reverse engineering things based on what the data it's received, and it's learnt what the world is, how it's actually behaving. Intuitive physics. I think that's the astonishing thing. Really astonishing. And actually, we that's what we do. Actually, when we're looking at something like a staircase, we don't understand the physics at all. We're just looking at it and saying, well, I know what it is like to go up a staircase, and this is fitting my model. That's what we're doing. So I think it's telling us how we operate. Yeah, with intuitive physics is what the brain is doing, I think. Yeah.
So on that point, thank you for the talk, first of all. On that point of the intuitive understanding, I'm curious about how the AI field of research is trying to interpret where AI learned these surprises. Let's say how GPT learned to translate languages without being trained, and how these models know how to go up the stairs. How is the researchers interpreting why this is happening, and what are their, I guess, consequences or result, or what are they acting upon it?
That's a good question. And I wrote a paper. I wrote an abstract for a conference, and I discovered I couldn't work it out. In the sense that I was looking at emergent capabilities and saying, does this term emergent relate in any way to the emergence of Stephen Johnson, of swarm intelligence and all that stuff? And the real problem is that we don't understand what emergence is. I mean, John Holland wrote the book on emergence initially. He didn't give a definition because he wasn't sure what the hell it was. And then, our brains are black boxes, and neural networks are pretty much black boxes too, despite what people say. So we really don't know what's going on. But I think it's confusing. The term emergent is accidental, and actually, really, what's happening is what happened in that Genie 3 video. We're figuring out by reverse engineering, based on intuitive physics, what's happening. I think that's all. It's just looking at the data and working out, well, that's how you. Which is actually what we do in some ways. We immerse ourselves in a different language. I mean, Hiroshi did this, right? From Japan. He didn't study in the States, and he learned the language by immersing. I think we do this in architectural culture. You go into an office and you absorb the culture, and that's the way we learn, ultimately. I mean, nobody teaches you what something beautiful is. You just kind of learn from, it's finding, yeah.
I want to say thank you, Neil. This was wonderful. I know that Neil has to fly back, so we have to make sure that keep moving. And we have 1 more hour to go. I want to say thank you. I want to say big shout out to Digital Futures. And if you are not aware of it, follow their channel. It's all free, open source, open access, to open up the education. And they bring this incredible lineup of speakers, thinkers, philosophers, and neuroscientists to enter to discourse that what does it mean for the creative community to think about AI and new emerging technologies. So I want to thank you, Neil, for your contribution. Thank you for a wonderful lecture, and thank you.
Yeah, I write a lot of books, but books are pretty much obsolete, right? They cost too much money. They take too long to come out. They're out of date before they come out. Podcasts are very fresh and very immediate, and they're all free. So make the best of it. Thank you. Okay.